Hello and welcome to another That's Just Wild Q&A, where we answer your burning questions about wildlife and nature. I'm Steve Baxshall, and as always, I'm joined by...
Me, Lizzie Daly.
And me, Sarah Roberts.
For ad-free listening, our newsletter, special deep dive episodes and members-only benefits, you can subscribe to us at that'sjustwild.com.
Okay, first question is for you, Steve, and it comes from Instagram from Rob Wells. My question is a strange one, but one that's troubled me and my partner for our entire stay in Tunisia. Tunisia has some native flamingos, and every single night, without fail, 500 to 600 fly over our hotel between 7:30 and 7:45 every single night. My question is, why? Where do they go? Why is it at the exact same time every single night? It's truly one of the most beautiful things I've ever seen. Just so confused as to why they do it. It's a great question.
First up, Rob, you're in Tunisia. You're in a beautiful, stunning place, presumably on holiday. Why are you troubled by flamingos?
It sounded like a humble brag, wasn't it?
What is it about them that is causing you sleepless nights? I think you need to reassess your prerogatives, my friend. But secondly, I think, first of all, flamingos, what an oddball animal they are. I am, though, for the duration of this, going to call them flingamingos, because that's what they're called in my house. My kids still call them flingamingos. So that's what they will always be to me. And they are one of the strangest of all animals. So I was in Namibia with my wife, Helen, watching flamingos, and we found a dead one. And obviously, being a nature geek, the first thing I did was have a look at the beak and what's inside of it, because it is so bizarre. It's covered with these kind of weird teeth all along the upper bit of the beak and over the tongue. They feed upside down, so the head goes down, upside down into the water, and moves from side to side, filtering out all these little brine shrimp that they feed on. And as a side note, I should say, flamingo tongues were a delicacy in ancient Rome, which it instantly throws me back to the life of Brian and the guy wandering through the audience going, otters' noses, flamingo tongues, badger spleens, as like tasty snacks for Romans. They'd eat anything. Yes, an utter oddball animal. The answer to your question is not perhaps as simple as it would like it to be, because the research that I've done shows that they don't tend to kind of move at the exact time of every day from one place to another. That it tends to be much more broken up than that. So what you're observing is quite unusual. Flamingos will move from their feeding grounds that they're active in during the day to somewhere that they may roost at night, or sometimes they carry on feeding through the night. But generally speaking, that is driven by the when it gets dark, what the weather conditions might be, the presence of possible predators. Sometimes they will not go to a roost at all, and they will just stay exactly where they're feeding, standing usually on one leg, and just resting in that place where they've been feeding. So why they're doing it at the exact same time of night, flying from one place to another where you are, is anyone's guess, really, and is actually really interesting, particularly if it's 500 or 600 birds. What a sight that must be. One extra last thing that I want to throw in, because I haven't really managed to answer your question, so I'm going to give you one extra fact, which is people have long puzzled about why flamingos choose to stand on one leg. And one of the kind of prevailing thoughts was because they're standing in very hot or very cold water and they're reducing their exposure to that heat or to that cold. But there's been a really rather wonderful experiment done using dead flamingos, using cadavers of flamingos, that shows that they can pretty much lock their leg in place and then balance on one leg using less energy than they would standing on two. So they've managed to get this bizarre balancing act going on where the bird is sitting on this weird monopod of a leg, and it's so energy efficient that it works better than being on two, which is totally counterintuitive, but appears to be the reason why flingamingos stand on one leg. Oh, and one interesting thing, I did a little bit of reading around this, and one interesting thing that I didn't know before I got stuck into this is that it appears that the flingamingos' closest living relatives are the grebes, which seems bonkers until you look into the eye of a great crested grebe, and they have this incredible red eye with a very strange shaped pupil, and it looks just like a flamingo eye. So that's the little bit that I garnered from your question there, Rob.
What does a grebe look like again?
So there's several different kinds of grebes. We have about 4 different species that rock up on British shores. Probably the best known is the great crested grebe, which is this glorious bird with a huge flamboyant crest, known for the dances they put on during the spring and the late winter. And they have a burning red eye. They're a water bird that's quite vocal, quite visible, very well studied. And yeah, it appears that when you start properly looking into the taxonomy of it, flamingos and grebes are closely related. So I've totally failed to answer your question, but hopefully I've chucked in a few good facts.
I love that. I love at first you were mocking Rob, saying, I can't believe this is keeping you up at night. And now we just know this is going to keep Steve Backshot up at night, is why are the flamingos moving?
Can we just go back to that question? Because I think it's kind of got me thinking about some of the pulses of movement that we even see, in our gardens or, over our skies. For me, I recognised a flock of gulls that would move every morning and every evening over where I grew up. Without fail, you'd see it kind of just going over the garden. You see it with starlings, that they pulse from roost sites to feeding areas and agricultural land. So these pulses, I guess, perhaps go unnoticed, but they do happen, don't they? So could it be, Steve, that, there is something, a really rich resource that is driving that movement, to that exact time every single day?
There you go, Rob. What she said. Lizzie answered it better than I did, that's for sure.
Get filming it, get the notes taken. You never know, it might be a new paper, that.
Fantastic, there you go. Now for you, Sarah, from Judy in Lancashire. I've been enjoying dining outside with our summer weather, but once the sun sets, I'm often joined by a lot of uninvited visitors. Why are bugs attracted to lights?
We've all been there, haven't we? I know, actually, for me, the place that stands out the most is the Australian outback, when we did a beautiful candlelit dinner after one of our hikes, and it was the biggest mistake ever because there was just crickets and massive cicadas and all sorts of things crashing into your back as you're trying to eat your food and knocking them off the plate at the same time. But actually, it's not what you think. I used to think that bugs were attracted to the light because they thought that it was the moon or they thought that it was the sun, but they're not actually attracted to the light at all. In fact, scientists have found that the bugs don't come from a long distance to that light. It only catches the bugs that are passing by. So they have something called a dorsal light response on their back. And if they happen to fly near to a light bulb, so an artificial light of any kind, then that glow, once it gets on their back, it messes with their brain. So if they're above it, what happens is they turn upside down and drop out the sky. And if they're below it, they start doing loop-the-loops. And then those angles that they're doing a loop-the-loop on gets more and more and more aggressive until eventually they also can drop out the sky. And if they're passing it side on, then what will often happen is they just really get confused and they just go round and round and round. And we've all seen this with bugs just flying aggressively at a light, like a moth or any kind of insect, really. But scientists studied it because they couldn't understand why bugs that existed in the daytime might be tracking towards any kind of moonlight, and this is it. It's actually not that they're attracted at all, but that their whole sensory system is being completely confused and obliterated by these artificial lights, which is, I know you're a bug man, Steve, and you do a lot in terms of bug conservation and trying to raise awareness of that. This is actually quite a shocking issue when you think about it, with the amount of artificial light that we have, especially outdoors right now.
That's so intriguing, your answer to that. I mean, first of all, I should say probably Judy from Lancashire, was probably talking about June bugs that is going to be bouncing off your lights in the early summer. My understanding was slightly different to that, actually. So I'm really intrigued to hear that answer, because I'd always understood that night flying bugs like moths, for example, do navigate using the moon, and they keep it at an exact set angle away from them. But because the moon is effectively an infinite distance away, that angle doesn't change. And if they replace it with an artificial light that is much, much, much closer, then they keep flying at that angle, and effectively they end up going in a decreasing loop and getting closer and closer and closer until they're bouncing off it, and then then they don't know what to do, which is different to what you're saying, isn't it?
Well, sort of, because the decrease in loop thing, I think, is the same. I think the findings sort of suggest that bugs like to keep that angle at a certain level, which would make sense for any of the moths or anything that's around at night time, because they would be used to that one light in the middle of the dark. But what I guess the scientists were studying it because they were so confused as to how the bugs that are usually around in the daytime are also getting so messed up by these lights. And yeah, that's what they found is if they hit it at the right angle, then they'll go round and round it. But if it gets that part of their back and sets off that dorsal light response, then maybe some are more sensitive than others as well, because different kind of settings, daytime and nighttime. But yeah, it's crazy, isn't it?
It's one that we, obviously it's a bad thing that our insects that are already under siege are now being attracted by endless artificial lights and finding it very difficult to go about their normal business. It is something that we as naturalists use to our favour. Moth trapping using lights at night is something that I do right here in the UK, and the results, the things that are living in your garden that you didn't know about, that you can attract in using a mercury vapor lamp, or even just using a white sheet with a torch shone at it, is remarkable. But have either of you tried doing it in the tropical rainforest?
No, I can only imagine. I mean, for me, the biting insects of the tropical rainforest are enough to put me off wanting to do that anyway. But I can only imagine the amount of diversity and crazy stuff you must catch.
So anywhere in the tropical rainforest, if you whack up a white sheet and shine a torch at it, what comes in at night is absolutely mind-blowing. You could have 300 or 400 different species of moths, praying mantises, every conceivable kind of bug. And it's one of the best ways of finding completely new species, because you can whack them up in a patch of forest and everything from miles around is attracted to it and will be bouncing off it. And after a little while, you also start to get things like bats coming in and feeding off the bugs.
I was going to say, do you get the predators as well?
It is just phenomenal and one of my favourite things to do in the world, although you do then spend the next 2 or 3 hours picking bugs out of your ear holes and out of your nose and stuff. But yeah, some of my fondest expedition memories have been from whacking up in fact, one of them we did on the top of an unclimbed mountain in Venezuela. It took us 5 days to get to the top of this thing, and then we whacked up a moth sheet, and within seconds it was covered in moths that were bigger than my hand.
Wow.
And dozens of them, probably completely new to science. It was really quite something.
Next question for you, Lizzie, and this one came in at Cheltenham Science Festival.
Is it true that elephants can communicate with each other even when they are over a mile apart? And if so, how can they do it?
Love this question. I've just been out in Sri Lanka, actually, spending time with elephants, and it's a rare opportunity for me because I absolutely adore them. But a rare opportunity for me to just spend time watching some of their behaviours. So, firstly, it is true. They do communicate over huge distances. And this has been studied by using something really cool. It's called a playback experiment. So scientists have essentially been picking up on rumbles that these elephants produce, these audible ways of communicating between elephants, within herds, across to other herds, and playing them back. The beauty of using these playback experiments and speakers in particular is that they're able to expand that range of hearing and the hertz level that is well below ours. And that is really where the sweet spot is for this infrasound communication, which is essentially production of kind of low frequency rumbles over potentially up to 10 kilometers away, but definitely several kilometers away, to chat to other elephants. And it's particularly good in optimal conditions, like if it's cold, if it's dawn or dusk, if it's nice and quiet. And the reason this is important for elephants is to just learn about the environment around them, to signal to others about where they are. If there's a male in must, for example, if you're just, wanting to also just keep checks on each other. They are a very social animal, so it's a really important way for them to be able to actually do that. How they do it is also very, very cool. So for a long time, they thought it was kind of this expulsion of air through the lungs and through that kind of larynx that they've got. but they've actually got vocal folds that really helps them vibrate and pass through air in quite like a passive way. So it's an easy way of them to communicate. And the other really, really cool thing, and something that I've seen, I mentioned Sri Lanka, but you see these elephants do it when you spend enough time watching them, is their feet and the tips of their trunks are incredibly important to be able to actually listen out for these rumbles. So in their feet, they've got loads and loads of specialized cells that pick up these vibrations. And similarly, in the tip of their trunk, they'll kind of lie it on the floor and press it to the floor and move it around as they're trying to pick up all these vibrations. So yeah, they absolutely can, and it's a very cool way of actually communicating over huge distances.
So it's not actually that they're listening; they're kind of feeling it instead. That sound.
Yeah, exactly. So that signal essentially travels through from their feet up to their limbs, and it's transmitted to their ear via something that's called bone conduction. So it's another way of sensing. And I mean, we've heard about, I guess, vibrations and the importance of low frequency bellows in other species, not just elephants. We know that, some birds, like cassowaries, do it. Alligators use low rumbles as well. So it's a really cool way of communicating.
Yeah, classically, blue whales can use it to create sounds that may be as loud as 500 decibels, which is an insane sound, but you wouldn't be able to hear it yourself if you were up close to it. Yet it can cross an ocean and another blue whale can hear it. Back to the elephants, though, some of their sounds you can hear. It's the most incredible low-pitched rumble. Others you can only feel. So you can feel if you're sat in a game viewing vehicle, you can feel the vehicle vibrating. We had a shoot a few years ago in Namibia, and we were at a watering hole alongside a group of maybe 40, 50 elephants all together. And I was doing a piece to camera, and halfway through it, I just kind of went, I've just got this really weird, unsettled feeling. Everything just kind of feels a bit weird and wrong. And we got our sound recordist with his highly sensitive microphone to do a frequency shift, a pitch shift. And you could hear the elephants were making those sounds. They were too low for us to hear, but you could feel it. You could feel it through your body, even though you weren't necessarily aware that you were hearing it. It was the most incredible thing. And you got this kind of like sort of sound, which, as you say, will just travel for miles and miles and miles, but is just that bit too low for our human ears to hear. That came from friend of the show and science presenter Maddie Moat. We love Maddie.
Yeah, thanks, Maddie. It was a really good question. Okay, final questions for you, Steve. I saw and heard in one of your recent Deadly 60 programmes about crazy sounds made by termites. How on earth does that work?
So first of all, to anyone that hasn't seen the programme, let me play you the sound, because it's like this. So we recorded that in Zambia last year. We were basically filming in a patch of forest and found this log which had clearly been taken over by termites, and they munch up the wood matter and they mix it with their spit and turn it into a crust over the surface of the log because they're highly photophobic, that is sensitive to the sun, so they protect themselves inside. And if you just tapped on the wood, this incredible alien sound would ripple all the way through the wood, creating this phenomenal, strange, spooky alien sound. And effectively what they're doing, because we filmed it in super, super close up, is each individual termite, which has a gigantic head and big set of jaws that they use for protecting themselves, will shake that head at hundreds of times a minute, and they bounce it off the walls around them. They're bouncing it off this encrusting in their little chambers, and it echoes within the tunnels that they've created inside the log. And then they pick it up and it runs from bug to bug all the way through the wood. So you've got this kind of phase synchronization going on through the wood. It ripples backwards and forwards in its sound. And that is said to sound, perhaps you could say, like the hissing of a snake. So it could sound like the hissing of a puff adder, for example. And any animal that came nearby and heard that would think there's danger around and give it a wide berth. This is, though, just the beginning of the different ways that termites have of defending themselves, the coolest of which is surely the Fontanella gun, which is this way that they have using their heads to fire out a sort of viscous spray which can entangle or irritate or completely overwhelm anything that they're going for. It could be an ant, it could be a spider, another bug. They can even self-sacrifice, splitting and rupturing their bodies to release all kinds of defensive chemicals. So they sacrifice themselves for the good of the colony. So there's all these amazing ways that termites have of defending themselves. And I mean, one of the biggest is the fact that they can create these structures. They can create really solid, concrete, rock-hard structures to protect themselves within. And it happens really, really quick. So way back when we were working on the Really Wild show, we dug out a little piece of a termite mound and we placed the Really Wild show logo inside, sat back, had a camera recording it, and the termites completely covered it over in about 10 minutes.
Wow.
And then it set as hard as concrete with the Really Wild show logo set inside. It was awesome.
Oh, cool. I'm still getting past the bit, though, where you said that they make the sound by essentially thrashing their own head against a wall.
Yeah.
Come on.
Yeah, they are genuine headbangers.
Yeah.
Genuine headbangers. I just don't know how that evolved. Do you know what I mean? Like, over time, evolutionary, surely their head is perfectly adapted for headbanging. But how does that even begin?
Yeah, I mean, it could be because they have big, visibly obvious heads and jaws, and moving them about from side to side could be a visible cue that you've got big weaponry that another animal might not want to mess with. And over time, that starts banging against the substrate and creates a sound, and then it builds up and builds up over millions of years, because these are ancient insects, have been around for a long time. But yet again, I am just making that nonsense up off the top of my head, Lizzie. I mean, who knows?
I'm only saying this, by the way, just to as a point of discussion. I'm just kind of genuinely interested to know, because also I guess for a lot of underground or for lots of insects and ants and termites, using that sound and vibration and how that kind of can travel was probably to a massive advantage. It travels further than, say, with scent or visual cues. So I'd imagine that's probably how it began. But it's amazing. Right, I think that's all we've got time for this week. Send your questions along to questions@that'sjustwild.com. and we'll answer them on the show. That's Just Wild is an original Fresh Air production. Its producers are Eva Higginbotham and Izzy Clark. And remember, you can follow us on your favourite podcast app. Leave us a review. It makes all the difference to the whole team. And for ad-free listening, our newsletter, special deep dive episodes and members-only benefits, you can subscribe to us at that'sjustwild.com. Remember, we're on YouTube, TikTok, Instagram, Facebook, and you can find us at That's Just Wild Pod. Thanks for listening. See you next week.